Vintage radios like my Heathkit DX-60 use rotary switches for function selection and other user controls. Those switches are notorious for requiring increasing amounts of torque to turn as they age, which eventually leads to the knob spinning. So the user responds by just honking down harder on the knob attachment screw. The switch gets worse, the user tightens the knob even tighter, and this race finally ends when either the switch completely binds up, or more commonly, the knob cracks. All 5 of the small knobs on my DX60 project are cracked. So I decided to repair them, and to do it in a way that makes them stronger than ever. That means putting a metal insert in them, like this knob. The best way to make this style of knob is a process called insert molding. Now, I can't do that here, but I did come up with a method that's just as strong. My approach used a carbon steel shaft collar. This is a very common mechanical part that's available from catalog companies like McMaster-Carr. It has a 1/4 inch ID to match the shaft diameter, and the outside diameter is a 1/2 inch. That will fit inside the knob. It won't just drop into the knob though. I'm going to have to remove a lot of the interior plastic to make room for it. Now you can probably do this with a Dremel, but I happen to have a small vertical mill, and that's a much better tool. It has a rotatable vise, so after I used a dummy 1/4 inch shaft to center it, all I had to do was shift it slightly off center and spin the vise by hand to start removing plastic. The knob itself is pressed into a 13/16 hole bored into a scrap piece of wood. I wrapped it with masking tape to make it fit tightly to the hole. A perfectly centered pocket isn't needed here, I just needed to remove enough material for the collar to fit. Then I milled the pocket to a depth that puts the set screw on the collar aligned with the existing hole on the side of the knob. Now that worked out nicely because there's still a little bit of the original bore remaining. That let me center the collar to the knob later. The existing set screw hole needed to be enlarged slightly. A 3/16 drill bit twisted by hand worked great. I used epoxy to secure the collar to the knob, but before I did that I needed to cut some notches in the collar. Otherwise I'd be relying only on the adhesive bond strength to the outside diameter of the collar to keep it from spinning, and I want a mechanical lock. Back to the mill. It was quick and easy to machine some notches. Again, I don't need anything precise here. A hacksaw would have done the job too. And speaking of the epoxy, this is what I chose, JB Weld's Plastic Bonder. It's got the properties that I want, including material compatibility and a decent working time. There's a few more prep steps that I needed to do before filling the knobs with epoxy. I needed a dummy 1/4 inch shaft to center the collar, so a few 1/4 inch drill bits and even a grinding tool worked just fine. And I needed to install a longer screw to position the collar axially and not block the screw with epoxy. For this specific collar, the screw size is an oddball M4.5. One final step, I didn't want the epoxy to stick to the shafts. That would have made their removal very difficult, if not impossible. So an easy fix for that is to just wrap the shaft with a couple layers of masking tape. Now I'm ready to mix and dispense the epoxy. Unfortunately, this part of the process turned out to be ridiculous. The epoxy is about as viscous as honey, so I thought I could just mix it in a small cup and then load it into a syringe. Well, that was a near disaster. Even with a 2mm needle, I could barely draw it up into the syringe. I got some dispensed, and then I tried to refill the syringe, and that just was not working. I was just drawing in a bunch of air. So I switched over to try to fill the syringe from the back, which I originally didn't want to do because of all the air that would be entrapped. And of course, I even dropped the syringe at one point, and that got epoxy everywhere. But in the end, I did manage to get enough in the parts. It says you can sand this stuff after 30 minutes, so you would think it was pretty cured by then, but I left the parts to set overnight anyway. Next steps were to remove the temporary set screws, then remove the shafts. And here's where the genius of the tape comes in. All I had to do was cut the tape at the top of the epoxy. Then the shafts were easy to twist out. There was no epoxy stuck to them. I could then peel out most of the remaining tape from the hole. Last step was to reinstall the set screw that came with the collar. These are a bit tiny and they don't have a lot of threads, so getting them aligned without cross-threading them is a bit tricky. But once they're in place, the knob is ready to go, and these knobs now are rock solid. I think this turned out to be a great method to salvage a vintage knob.